just before I start, my name is Dr. Mark Gallaway. I'm a science communicator, as that's my principal job. I'm a trained astrophysicist. So science communicators, we basically explain science to people. So it turns out that most scientists are really, really bad at explaining things. So that's basically what I do in my job. I work with other scientists, but I do research myself, but not so much these days. So today we're going to talk about a subject which is astrobiology, also xenobiology. So the two are slightly different. So astrobiology is looking for life that looks like life on Earth, looking for outer space. So we're going to be talking about that. Xenobiology is looking for life that's completely different. So it's looking at different ways. So I'm going to start off with my PowerPoint. Here we go. So hopefully you can see that. So where are all the aliens? Okay, so 15th of August, the Big Ear radio telescope in Ohio picks up a signal which is coming from the constellation Sagittarius. Lasts 72 seconds, which is the max amount of time. It's the most powerful signal ever detected. So the WOW signal is called WOW because the it's my slideshow is doing things it shouldn't do. Hold on, is that better? No, it seems to be progressing on its own for some reason. It wasn't doing that beforehand. Okay. I'm going to just restart my slideshow. I do apologise. It wasn't doing that about 10 minutes ago when we were testing it. So we're going to have to go to slideshow setup. Oh, wait. Okay. Okay, that's better. Let's go through. Okay. So that's the only signal. Oh, still doing it. That was the only signal that we've ever detected from space that I'm going to stop doing my PowerPoint like that. It's the only signal that we've ever detected from space that's ever been close to being an alien signal. Okay. Are you not seeing our screen? Can someone just confirm that they're seeing my screen or not? Yeah, unfortunately, for some reason, it keeps on wanting to progress. So hold on, let me turn a couple of things off. It's doing something weird, which it wasn't doing. Let's try that again. So give it a few more seconds. So it seems to be wanting to auto scroll through. So let's hold on. Ah, it seems to have stopped doing that now. Okay, hopefully it stopped doing that. Okay. So that was the strongest signal we've ever detected from space that's been unexplained. We've detected other signals from space before, but this one's largely unexplained. I personally don't think it's extraterrestrial. I've always thought that the WOW signal is probably a radar signal that's been reflected off of space junk, but that's never been confirmed. So this led to a couple of questions. So that's just introducing me. So this is Enrico Fermi. He's a Nobel Prize winning scientist. He's unfortunately now deceased. And he asked a very important question, which is if intelligent life is really, really common in the universe, where is everybody? So we literally have not seen any possible alien signals except the WOW signal, and that is really controversial. So because the WOW signal was only ever detected by one radio telescope and it was only detected for 72 seconds, and also the fact it was never repeated, it makes people very skeptical whether it was extraterrestrial. There's also no data inside it, and that's the other issue. So if aliens were trying to communicate with us, surely they would try to communicate in a way that we would understand, and there's no data inside the WOW signal. So Frank Dyson, a few years later, came up with this idea that he could work out how many intelligent civilizations were in the Milky Way. And he came up with this, what apparently is a very, very scary equation, but it's really, really easy. It's just a number of numbers multiplied together. And those numbers are the number of stars in the Milky Way. By the way, this is a modified version of the Drake equation. Since Drake wrote this original equation, we've learned a lot more about how the universe is evolving. So this is what's called the modified Drake. So R star, which is the number of stars in the Milky Way, which we know, there's the number of planets per solar system. There's the fraction of planets that are Earth-like, the fraction of planets of Earth-like, the planets that gain life, the fraction of Earth-like planets where there's intelligence, and the fraction of those civilizations that arise that are detectable to us, and the fractions of those that remain communicable. And we're just going to go over what we think some of the numbers are for the Drake equation, because they're very controversial. So the first thing is number of stars in the Milky Way, and we know that really, really well. So if you asked me about 4 or 5 years ago how many stars were in the Milky Way, I would have said about 300 billion. Since then, we've got a new spacecraft, the European spacecraft. You can see a picture of it here. That's called Gaia. Gaia's been mapping the Milky Way to really, really high accuracies, really high precision, going deeper than we've ever been before. And we've up-rated the number of stars in the Milky Way to about 400 billion. So basically, we found 100 billion stars. It's a bit like when you find some change down the back of the sofa, except instead of finding a couple of pounds, we found 100 billion stars. But we're pretty sure that that figure's pretty much right. So we know what our star is, which is more than what Drake did when he first started working this out. So we're going to take 400 billion as our starting number. Please object if you don't like any of that. So Angels, it's still on the Fermi paradox slide. It should be moving on. I'm going to do a, hold on, I just didn't see. Hold on, I'm going to do a new share. You always get technical problems with these. Can you see that now? Yes, sorry about that. You always get technical problems always. Okay, so that's the number of stars in the Milky Way. So, okay, so 400 billion. So now the fraction of planets per solar system. So when Frank Drake came up with his equation, we had no idea how many planets were in the solar system and in the Milky Way. And I used to watch Star Trek, and Kirk and Spock and McCoy would go, and the security guard to show how the monster works, would go down to this exotic planet. But actually, at that time, we had no idea of how many planets there were in the Milky Way, and whether even there were planets around other stars. That has changed a lot. So there are 5 ways that we detect planets around other stars at the moment, but there are principally 2 main ways. And one of them you definitely would have heard of, one of them you might not have. So the first method is the transit method, where we look for a planet to go in front of a star, and that makes the star dim very, very, very slightly. And we see that is what we call a transit. And there's lots of telescopes now doing that now, but there's a very famous space telescope called Kepler, and you might hear when you hear in the news that a planet's being discovered, and it might be called Kepler 3472882b, and that's because it was discovered by the Kepler Space Telescope. And this is how we discover most of the planets outside the solar system now. They're called exoplanets, so they're planets outside. So we use the term exoplanet, exo meaning out. So about 4,500 exoplanets have been discovered that way. And in fact, it's so easy you can do it from your back garden. I've done it with relatively small telescopes. So I sometimes go out to Hawaii and Chile to use really, really big telescopes, but actually you can do it with a small telescope. The other way is to look for a star wobbling. So planets make stars wobble, believe it or not. So the Earth, and particularly Jupiter, makes the sun wobble, and we can detect that wobble using really, really big telescopes like the telescopes we see over here. These 2 telescopes are actually a pair of 4 really, really big telescopes in the Atacama Desert in Chile. They're called the Very Large Telescope. We're not very good at naming things, unfortunately, astronomers. We're building a new telescope that's going to be looking for Earth-like planets, and that's called the Extremely Large Telescope, because surprisingly, it's extremely large. So that gives us an idea of how many planets we think of in the Milky Way. And we think that the average solar system has at least 2 planets. It's probably higher than that, because at the moment we can only detect planets that are super Earth and bigger. So planets the size of the Earth, we still can't really detect them at the moment, but we're very close. And the ELT, the European Extremely Large Telescope, should be able to do that. So I'm going to make FP equal 2. So the fraction of planets that are Earth-like, and this is where things get really tricky. So we've discovered about 4,500 exoplanets so far. And the number that are Earth-like is 0. So don't believe what they say in the press. You see, journalists like to get really, really excited when we discover a new planet that's the size of the Earth. And the scientists might say, we've discovered this planet that's the size of the Earth. It might be Earth-like. And the journalists always miss the might be. And they might say, oh, we found a new planet like Earth. But we're nowhere near doing that. So at the moment, of those 4,000 exoplanets we discovered, none of them are anything like the Earth as far as we know. So I'm going to make the number of Earth-like planets very, very small. Okay, I'm going to make it less than 1.1%. So what I'm saying is that for 400,000, there might be 1. Okay. So the next one is the fraction of Earth-like planets with life. And this is where it becomes really, really tricky, because we haven't discovered any planets with life on it. even in the solar systems. It's just the Earth. Okay, so we are trying really hard. So the place we most expected to find life when we first started looking at was actually Mars, and we sent a number of spacecraft to Mars. And Mars used to be very Earth-like. We know it used to have a very thick atmosphere. We know Mars used to have water on the surface. This particular spacecraft here is Curiosity, and that's been looking for life on Mars. We're about to send a new one. It's Rosalind Franklin. It's a new European spacecraft. And it's the first Mars probe that's been designed specifically to look for life since the Viking probes in the 1976 probes. So they're going to be looking for life on Mars, but I am not optimistic. I think life's quite tenacious, and I think if there was life on Mars, we'd be able to see it by now. So there are a couple of other places in the solar system we might be able to find life. So on the right-hand side over here, this is the moon of Jupiter. This is Europa. Europa is quite a large moon. It's quite a lot bigger than the Earth's moon. In fact, it's nearly as big as the planet Mercury, and it's covered with all these stripes. And we've discovered that Europa is covered in ice, and it has an ocean underneath that ice. It's liquid water, and we think liquid water is needed for life. And it's got more water in there than all the oceans on Earth put together. So it might be a really good habitat to find life. And we're hoping to send a robot, can melt its way through its ice, so it can have a swim. But bizarrely, the most likely place for us to find life in the solar system is not actually Mars or Europa. It's, hold on, it's this thing here over on the left-hand side. This is Enceladus. It's a moon of Saturn, believe it or not. It's quite small. It's only about 600 kilometers across. In fact, if it was any smaller, it wouldn't actually be spherical. And we've discovered there are volcanoes on Enceladus, but they're not hot volcanoes. They're cold volcanoes. They're called cryovolcanoes. And we flew a spacecraft called Cassini through one of those probes, and it measured what was coming out of this volcano. And it turns out that there are organic molecules coming out. Now, organic molecules are the building blocks of life, and we have absolutely no idea what they're doing coming out of a moon of Saturn. So it could be some weird chemical processes going on in Enceladus, in the center of Enceladus. We know probably inside Enceladus it's quite warm, or it could be life. So yet again, we'd really like to go back and have a look to see if there's life on Enceladus. The other interesting place, and it's particularly topical now because there's a really bright comet at the moment called Gallaway. So if you have clear skies tonight, you go outside just after sunset, you might be able to see a Gallaway. It's quite a bright comet, really good on a pair of binoculars. We sent a spacecraft called Churyumov, to a comet called Churyumov-Cherukamenska. This spacecraft called Rosetta. It had a lander called Philae. And it found some evidence that there were quite complex organic molecules on comets, including some of the building blocks of life, some of the proteins and the amino acids that are needed for life. So now we have a problem is what is life going to use? So you probably all know that all living things that we know of uses DNA, and actually the DNA that we have in our bodies is very, very similar, for example, to the DNA a kiwi fruit has. Now, there is another molecule that life could use, which is RNA. And in fact, life does use RNA to transmit genetic information when it processes DNA. Also, viruses, which aren't alive, some viruses use RNA as well, but we don't know there's other molecules that life could possibly use to transmit information. And that's what life really is. Life is just a way of transmitting information. So as you breed, you pass on your genetic information, and that basically continues the species and slowly changes over time. So the other problem with life is life appeared on Earth very, very early. So life appeared on Earth within the first 500 million years. And it was prokaryotic, it was single cell, and it basically didn't do anything for about 3 billion years until it became eukaryotic, it became multicellular. And that, it looks like that's very, very hard to do. So it might just be the case that there is life out there, but it's all single celled. It might be the fact that life developing is actually quite easy because it happened quite quickly on Earth, but it might actually become very hard to become multicellular because on Earth that took a very long time. But you've got to remember that we've only got one example. We've only got the Earth. It actually might not really be like that. So we've got to be careful when we draw in lots of assumptions. Okay, yes, that's true, but I'm just making. Okay. So there are other things that are out there that called extremophiles. So extremophiles are very important when talking about astrobiology. So these are creatures that can live under very extreme circumstances. So probably you know one of these. This is a moss piggy, or also known as a water bear. or its proper name is a tardigrade. Now, tardigrades are incredibly hardy. In fact, they're found in pretty much every single environment on Earth. They're pretty much impossible to kill. And they can stand very, very low temperatures, very, very high temperatures. So we might be looking at environments that that we wouldn't find on Earth, so very, very extreme environments. We also find a life in very extreme environments such as this. So this is prismatic springs in Yellowstone National Park. And these colors are actually caused by a different type of algae who are living in there. And it's extremely hot. It's above boiling point in many parts of the lake here. And it's very, very acidic. In fact, it's more acidic than battery acid. So there's been a number of people who've had very nasty accidents when they fall into this, and basically they don't survive. But there's life living there, which is pretty amazing. Okay. So I'm going to go for the fraction of life on planets of 0.5. That's actually really, really high. So quite a lot of people wouldn't agree with me, but I'm going to go for 0.5. You can feel free to disagree with me. Okay. So what's the chances of intelligent life to appear? And obviously we've got no examples of that except for the Earth. In fact, we've got examples for life anyway. So it took about 3.5 billion years from the first life to appear to intelligent life to appear on Earth, and that's quite a while. But that would suggest that the fraction of intelligent life is greater than 0, but it's still very low. So I'm going to go for conservative 0.1 here. Okay. So what fraction of those are detectable? So that's ability to things that we can actually talk to. Okay. So, oh, by the way, so Robin asked the number of planets in the Milky Way. So we think it's about 1 trillion. Okay. So give or take. So basically we're looking for civilizations that can develop radio, and that radio is detectable over interstellar distances. So for humanity, we've been able to do that for about 70 years. So not listen, but to transmit. Okay, so we've been able to do that for 70 years. We've been listening for about 50 years. So we've got a program called CT, which is the search for extraterrestrial intelligence. They use a number of telescopes, including the Allen Array, which was designed specifically to do that task, to look for extraterrestrial signals. Okay. And there's also CET, which is to communicate with extraterrestrials. It's very, very controversial. So I don't know about you people, but do we want to be broadcasting our out into space to let people know that we're here? Now, some people say, no, we shouldn't be doing that, but actually it's too late. Despite the fact that we've already transmitted a couple of times anyway, there's the problem that the Earth is already brighter in radio waves than the sun. So the Earth is easily detectable by an extraterrestrial civilization with something like a SETI Allen Array up to about 70 light years. So if they're out there and they're relatively close, within a sphere of about 70 light years, they'll know we're here. So it's pretty hard to hide. Also, if they've got a very big telescope like the European Extreme Large Telescope, which is going to come in line in about 10 years, they'll be able to see our atmosphere, and they'll be able to see industrial pollutants in our atmosphere, which is another example of intelligent life, or maybe not so intelligent life in our case, is living on that planet. So I'm going to assume that that most intelligent civilizations will go on to develop radio. So I'm going to make FC equal 1. Okay, so how long do intelligent civilizations live for? And there's something called great filters. So these are things that can prevent a civilization from developing. So for humans, we've been around about for 250,000 years, and we've only had radio for about 100. So I'm going to make the chances of us being communicable, so we can still talk to aliens, quite small. So that's the figure I've got. Cool. Okay, and that will put the number of civilizations in the Milky Way that we could talk to. That doesn't mean that they're close enough to talk to, at about 1600, which is generally what a lot of people are talking about. So there are 1600 civilizations in the Milky Way. Where are they? Because that's quite a lot. And if you basically spread them over the Milky Way, we should be detecting at least one of them. There's also this idea that if you're really, really determined, even going sublight, so if you basically had generation ships, you could probably colonize the entire Milky Way in a few million years. And a few million years might sound a lot of time for you, but for the life of the galaxy, it's a very, very short period of time. And we're not seeing huge civilizations out there. Okay, so there's been a number of solutions to the Fermi paradox, and so basically the Fermi paradox is, where is everybody? So as I said, it should be right. So yes, so solutions to the Fermi paradox. So one of the ideas is what's called rare earth. So basically, extraterrestrial life is really, really rare. So it could be that I've just been way optimistic on some of those numbers, and that we could be the only in civilization in the galaxy, or there could be only one or two, which is a bit depressing, really. So that's called the rare earth solution, and actually, it's the one I'm probably most keen on. It could be that there's just no intelligent species arisen. That's the idea called the great filter hypothesis. So they get certain stages in their evolution that they can't progress. So, for example, at the moment, we have a major problem with climate change. If we can't deal with climate change, our civilization will collapse. Okay, and then we wouldn't be able to be communicated by other civilizations. Things like asteroid impacts, diseases. There are lots of things that can challenge a species. So it's this idea that there are so many filters that they can't get through and remain communicable with us. So there's this other idea that intelligent species, they don't have advanced technology, or they don't develop advanced technology. So they either stay at a sort of Stone Age level, they don't really ever progress, or the fact that we're the first people to get that kind of technology. That's called prime man hypothesis. As a scientist, I don't like that because it says we're special, but it is an answer. So someone's got to be first, and it could be us. So we could be the people who are going out hunting down life rather than being the ones waiting to be found. So there's the idea of a water world hypothesis, which is that Earth-like planets tend to be covered in water. So they would have lots of life, but it's very, very difficult to develop technology if you're an aquatic species. So if we look at the aquatic species that are quite intelligent, so we're looking at dolphins, we're looking at things like octopuses and squid, which are pretty smart. None of them really tool users. They have some extent of tool use, but they don't make fire. So having a planet that's completely covered in water would basically stop any advanced civilization evolving, as far as we can tell. This is quite a nasty one, which is, it is the nature of intelligent life to destroy itself. So one of the things that drives technology, certainly on Earth, has been conflict. So it could be the case that intelligent life basically ends up just destroying itself through internal conflict. Again, that would be really, really depressing. Oh, and we're just not talking about internal conflict. We're doing things like destroying their environment when they try to industrialize as well. Okay, nope, go my way. Okay. This is the scary science fiction one, that intelligent life destroys other intelligent life. And this is known as apex predator theory. So it could be that there's one civilization that's really large, that's a very, very aggressive. And the only way it's decided it can survive as a species is to stop any other intelligent species evolving. So they basically keep an eye out for intelligent species evolving, sending radio signals to come out into space and then coming along and stomping on them, which, let's hope that's not the case. It's sort of an Independence Day scenario. Certainly I would have thought we would have detected them, but it's a bit depressing if that's the one. So civilizations are too far apart in space and time. So that's basically saying that that there are too few civilizations. They rise and fall fairly quickly, so that we're not in the same epoch. So you've got to remember that humans in their current form have only been around for about 200 to 300,000 years. We haven't been civilized for that long compared to even how long humans have been on Earth. And it just might be a case that civilizations come and go so quickly that we never actually exist at the same time. Although you would have thought that a civilization that becomes so technologically advanced that they're capable of interstellar travel, even with generation ships, they probably wouldn't suffer from that kind of collapse, or they'd have partial collapse. But that is one of the possibilities. Again, lack of resources. So it might be just too hard to travel through interstellar space. That's very, very likely. You might be struggling to get out of your solar system. And in fact, you've got to remember that we're really struggling just to get out of Earth at the moment as a species. There could be just a lack of desire to live on other planets and a lack of desire to communicate. We make the assumption that we want to talk to them, that they might want to talk to us, but that might not necessarily be the case. Humans might not just been around long enough. So there is a limit to the speed of light. So speed of light is the ultimate limit to the velocity of things can travel. So 200,000 years just might not have been long enough for us to make any contact. And certainly human civilizations, like technological civilizations, hasn't been anywhere near that long. So it just might not be the case that we've been around enough. Okay. So, or we're just not listening properly. So they might not be communicating by radio, and that might be a really big problem. So we're looking at other ways. So this is the idea that they might be communicating optically, or they might be dropping unusual elements into their star, and that causes a change in the spectrum very briefly. Or they might be using something exotic like gravitational wave communication or neutrinos that we're not really doing at the moment. But certainly they might not be communicating in the way that we would understand, or might not be communicating in a way we would recognize. It might be the case that they are deliberately not contacting us, and this is the idea that the zoo hypothesis. So basically, we're like a zoo; they're observing us because we're a primitive culture. And I think this is the last one that's been suggested. There are about 50 explanations, but these are the main ones. That Earth is purposely isolated again. That it's a question of their reservedness, and they don't want to contact us or change us or evolution. Okay, so what do you think? So we're going to have some questions. So ask away. I am aware that eukaryotic cells aren't is not the same as multicellular, but they have to be eukaryotic to be multicellular. Frank. Has anybody got any questions? They're gone all go. So I mean, how many people there do you think there are aliens? Okay, they're coming in. Right. So is there a place in case there are aliens? A plan in place? Yes, there is. So the United Nations have got a contact plan. I'm not entirely sure what it is, but we do have plans to do with what happens here. Even the UK has an alien contact plan. And yeah, I think they are, if they exist. Yeah, I think they could be aliens. So what other questions have we got about? Do you think they would kill us or help us? Right. So I think that there's no point in traveling across interstellar distances just to kill us, and unless we've got this idea that they're worried about hostile civilizations. I think that's very, very unlikely. So if you're capable of interstellar travel, then resources probably isn't going to be a problem for you. So there's a good thing that science fiction writers do on very, very bad TV programs is that the aliens come from our water. Well, water is really, really common in the solar system. There's pretty much no element or no resource that they wouldn't be able to get hold of in their own solar system. I think they'd just be really, really inquisitive. So I think let's have a look. What are the biggest dangers of us exploring the place in search for life? Okay, so at the moment we're doing it all robotically, but the real challenge is distance, really. So places like Enceladus are just so far away. So to get to Saturn's going to take about 5 years. So it's not like Interstellar where you can just whiz over. So we're trying to do it all robotically, and don't forget we haven't been further than the moon as humans. So it's really tricky. And the other thing is recognizing what is life. We have a certain criteria for life. You probably remember your Mrs. Gren. Life might not be following that same route. So that might be a problem, that we actually find something that's living we just don't recognize. So there's quite a big argument in biological circles whether viruses are alive. We could find things that behave in some ways to life, but we're not entirely sure. I mean, we've got to look at what about machine based life. So there's this idea that some of the first life we might meet will be machines. So there's a concept called a von Neumann machine. So non-Neumann machines are self-replicating machines. So if you wanted to explore a galaxy, one of the best ways is to make machines that copy themselves. So they make more and more of them, and then eventually they spread out into space. I mean, they've actually lived forever. So we could be seeing that the first intelligent or first alien contact we have is actually with a machine rather than a living organism, which would be really weird. By the way, I'm highly against building von Neumann machines. They're potentially incredibly risky. So they could end up eating your entire solar system if they get out of control. So you have to be really good. Right, so we thought you were very optimistic about the number of Earth-like planets, which would have to go on to life. But yeah, I think the trouble is that we just don't know. So different people will come up with different figures. So there's some figures coming up that would say there were 10 million intelligent species in the galaxy. I just don't accept that. There was a recent academic paper which was very, very big on the news. I wasn't really keen on that paper. It said that there was between 2 and 200 civilizations that were in communicatable range. And I'm way under that. Okay, so it should be 2 or 3. The trouble is that we just don't know how many Earth-like planets there are. Okay, so I'm saying less than 0.1% of planets are Earth-like. If you look in the solar system, Mars just about is Earth-like, just about. So that's why I sort of went for about 0.1%. Okay, but you're quite right. I'm not defending any of these numbers. Do you think alien life will evolve faster than us? And that's a really good point. So life on Earth hasn't evolved at the same rate. So you see things like the Precambrian explosion where life evolves very, very, very rapidly. So there might be a case that they get very, very rapid evolution. In fact, we see very rapid technological evolution on Earth. So conflict tends to drive evolution on Earth as well. In fact, conflict between species tends to drive evolution as well. Have I ever been to the International Space Station? No. In fact, actually, not many people have been into space, only about 700. And to be brutally honest, I don't do well on roller coasters. So I think if I went, I'd just throw up all the time. So I really, really don't want to go. Okay, but don't let me stop you going because it'll be an absolute fantastic experience. Do you think they're aliens? Definitely aliens. I'm sorry, I'm just running. What are the challenges to building a generational ship? Okay, so the real big challenge is propulsion. Okay, so at the moment we haven't got any real propulsion technology that could send us to another star that doesn't involve nuclear weapons. And basically, there's an idea of this Orion spacecraft where you basically set off small nuclear weapons and use that to drive you. But the main problem is trying to keep the environment constant. So you always get leakage from any environment. So the Earth at the moment, it leaks air a little bit. Okay, so you can't recycle anything forever. So the Earth's done quite well. It's recycled. It's got the water cycle. It's got the carbon cycle. It's doing quite well. But for a small and closed system, you're always going to get leakage. So every time you open an airlock, you lose a bit of air. So if it's going to take you 10,000 years to get to a star, how do you maintain that? So it's really, really difficult. Are there any Earth-like planets? At the moment, that came from Sam, Miles, and Nick. At the moment, not that we know of. So the ELLT, which is a telescope that's going to be 32 meters in diameter, and that's being built in Chile right as we speak. One of its missions is to try to find Earth-like planets. So we'll do that by looking at the atmosphere. So we're looking for biomarkers. So we can do something called spectrography, which is looking at the light, and inside the light you see indicators of what's in the atmosphere and on the surface. So we're going to be looking for things like oxygen. So free oxygen suggests there's life. We'll be going to be looking for things like methane. So free methane in warm environments suggests that there's life. Yeah. And the other thing we're going to be looking for is chlorophyll. So if we see chlorophyll, that's a good indicator that there's life as well. But then again, if there's another way of doing photosynthesis, we'll be in trouble. Fastest thing rocket has ever reached. I actually don't know the velocity. The fastest spacecraft we've ever made is New Horizons. So that got to Pluto in 7 years, but it's really, really slow. And it's going to take New Horizons about 40,000 years to get to the next star. So it's really, really slow. I don't think going So we've had a question from Robin about going for faster than speed of light. I don't think it's possible. So Einstein doesn't actually say you can't go faster than the speed of light. He actually says information can't be transmitted faster than the speed of light. You might be able to do it through warping space, and there's been some ideas about this, but you need very, very exotic matter. You need things like negative energy, which we've never proved it exist. So it might be the case that we just don't go faster than light, which would be a real downer, to be honest, because I'd love us to be able to go faster than light. Do you think they'll overtake humans on the food chain? No, because I think once you're so technologically advanced, you'll reach a point where you're not resource limited. Okay, and once you've got that point, you basically don't have to worry about food, so that's no problem. Do you think right? So I can from the question from Robin, do you think the universe will expand and collapse? We actually now pretty much absolutely confident that the universe is just going to continue expanding forever, and that's because of dark energy. So dark energy is making the expansion of the universe accelerate. So we're thinking about 10 trillion years, the universe is going to start running out of energy, and some point after that, if it continues expanding at the same rate and accelerating expanding, actually space and time will start pulling apart. There might be a big bang after that, but who knows? What would you do if aliens came down and landed in your garden? There isn't much room to land a spacecraft in my garden. I'd have some really interesting questions for them, I think, how did you get here? And how did you solve some of the generational problems that you've had and all the challenges that we have? And by the way, is quantum mechanics real? And quite a lot of things I'd quite like to learn. Would humans take their habitat? I certainly hope not. Actually, I don't think humans will be able to survive in a lot of alien habitats. We're basically evolved to live on this planet, and we're very, very sensitive to certain chemicals and certain elements being in the soil. So things like phosphorus and potassium that we need, it has to be in the right concentrations. If we get too much of it, it kills us. If we don't get enough, we can't function. So there's going to be lots of problems if we move to another planet like Mars about having the right kind of nutrients, and we're going to have to take a lot of those with us. Where should we go? Well, I think if we build a generation ship, I think we've got to look for planets that we think are Earth-like, and we should go there. Steady state, no one really believes in steady state. Okay, so this so someone's asked here about the Big Bang theory of steady state. So steady state was the original theory that the idea that the universe had never changed, it always looked the same, and steady state's been dead for quite a long time. There's way too much evidence for Big Bang now, or actually Big Bang isn't the proper name for it. The actual proper name for it is the expanding universe theory. The evidence for it, the expanding universe theory, is overwhelming. Given that it might not build a civilization, how many millions of it? Yeah. How long would it be for us not to be able to detect a civilization? So it depends on how long. I think the big indicator would be the change in the atmosphere. So it might take about 100,000 years or something for an atmosphere to revert back to normal, probably quicker than that. You've also got the radio bubble going out, so the radio signals that are traveling out into space. Eventually, as that bubble gets bigger, the surface area of that bubble gets bigger and eventually that signal will be not detectable. So I reckon the best indicator that there's been a civilization there not actually visiting and looking at their structures would be the atmosphere, and I think that probably would go quite quickly. Interstellar travel possible? I suspect it isn't, and I suspect that's the answer to the Fermi paradox. I think interstellar travel is too hard, and that's why no one's coming here. What's the problem building a stellar engine to preserve life? Again, we don't have any technique that will make us go really fast and look after to keep the environment going. It's really, really tricky to make any kind of engine that's going to get us going into space long term. There's a evolution from the pre-Cambrian. Yeah, I'm not an evolutionary biologist from Katie, so I wish I was an evolutionary biologist. You need to ask an evolutionary biologist for that. So there is some argument about the Precambrian explosion. So that there've been constant evolution, and you get the explosion. Something obviously happened around that time, but there's some people arguing now that it wasn't as big as we thought it was, and it's just us not understanding the fossil record. Okay, right. I think we've got to. Could aliens hold the future in helping us solve? Yes, definitely. So if you've got to a point where you've already sorry, Danny's asking, could aliens hold the future to help solve and fix climate change? So presumably they've already come to this problem, they've got a solution. So there are a number of solutions. So one of the big things we've been trying for a very long time is to get fusion power. So the sun works by nuclear fusion. Nuclear fusion is pretty clean. It doesn't have any radioactive waste like you get with fission, but it's really, really hard to do. And it would completely solve our energy problems overnight. We're building a test rig out in France at the moment called ITAR, which is probably the most likely project to actually do nuclear fusion. But there are other programs going on as well. Some people are looking at doing shortcuts for not doing hydrogen fusion, but fusing someone else. But that's the sort of thing we need to know. We need to know how to make lots of power very, very cheap and very, very clean, because it's actually our power generation that's causing a lot of the problems. Other questions, what A levels? My A levels are not entirely normal. Okay, so the normal route that people would take is that they would take science A levels and mathematics. So I'm an astrophysicist. So so my students and the people I work with, they would tend to do physics and mathematics and another science. Languages are really, really good if you want to do astrophysics, and then you'll do a physics or astrophysics degree at university, and then you probably should do a master's degree, though you don't have to. There are two types of master's degrees. There are taught masters and the masters by research. If you want to do research, I suggest you do a master's by research, and then you have to do a PhD. Unfortunately, you need the PhD to get access to the funding, to be able to use all the telescopes, etc. So, and then basically that's the route you take, but definitely take maths. So if you're doing any science, maths is really, really important. Our evolution clearly slowed. Do you think if we had a reason for comfortable? I think it's difficult to say whether our evolution has actually slowed. Katie, I think that evolution is a very, very slow process. I think that we're obviously negating some of the evolutionary pressure, because when we, obviously people don't die so often, and there aren't so many environmental risks. But yeah, I think it's probably going to be an issue. We might end up with larger brains and being more intelligent. Okay, so there's a problem with having a really large brain. Okay, so brains take an awful lot of energy to keep going, and I think if you look at the creatures that are reasonably intelligent, so we're looking at dolphins, we're looking at other primates, they're all roughly the same size as us. So I think brain size to body size ratio is really, really important to how life evolves in intelligence. So I think that we're not going to get more intelligent. And actually, I think there's a problem. We might get less intelligent as we rely more on technology. So I think that's a real big problem, actually, as we rely more on technology, that we become less intelligent, less capable of doing things on our own. Do you think Mars had life on it at any one point? I think not, but the only reason why I think not is because we haven't found any. And I think that life is so tenacious. If you look on Earth, life's everywhere, literally everywhere. You can look at it in hot thermal springs, the coldest places on the planet, the dry valleys in the Antarctic where it just hasn't rained for thousands of years. There's life there. And you would think if life could exist or had existed from Mars, it would have been able to cope. So Mars's climate's changed, but it didn't change dramatically over a very short period of time. It changed very, very slowly over a very long period of time. And I would be surprised if it couldn't evolve to survive. Perhaps we can find something. We are definitely looking for examples of fossils. What do you think happened before the Big Bang? Right, so this is a really odd question. So that actual question doesn't have any meaning because as far as we know, there was no before the Big Bang. So time started with the Big Bang. So it's sort of a bit like asking, what were you doing before you were born? So it doesn't really have any meaning. Can no particles go through a black hole? That's from Fran. Oh, Pran? No. So anything that passes through the event horizon of a black hole is stuck there. Do I believe in wormholes? No. Okay, I think that they don't exist and there's no evidence. And do you think string theory is not a discovery? So Pran is also asking about something called Robin's asking about string theory, sorry. And string theory is one of these ideas that tries to resolve quantum mechanics. String theory isn't going anywhere because it's not making any predictions that would distinguish it between string theory and quantum mechanics. So I think that at the moment, certainly string theory is a dead end. Shouldn't we go on Mars and terraform it as soon as possible, not worry about what might be further? Well, that's okay. Yeah. Okay. So so Alina said, should we just get on with terraforming Mars and not worry about the fact that there's been life there? I think we should have learned our lesson that destroying environments is really, really bad to do. And we're nowhere near the technological level that we would need to be able to terraform Mars. We're just nowhere near it. We might be in 200 or 300 years, but we're just not there. Therefore, what we really need to do is explore Mars and get some understanding of the environment, because that will be able to tell us whether we can live there without doing significant amounts of terraforming. Can we harvest energy from black holes? From Robin. The nearest black hole is about 3,000 light years away. So the answer to that one's no, unfortunately. So black holes aren't really a good way of doing power sources anyway. How are we getting on? I think I've almost caught up on you. If I haven't answered your question, please just put it back in again, because I haven't been able to see all of them. I'm not sure what you mean, Robin, by a stellar engine. Are you talking about something that could enable us basically to fly to the stars? And if that's the case, the problem is we just don't have the technology. We just don't have the technology, and there doesn't seem to be any route for us to do it. So even if we build something like an Orion engine, which basically uses small nuclear bombs to power it, that's still going to take a very, very long time. So the basic problem is the amount of energy you get out of the fuel. And at the moment, we haven't got any way of doing that. Fusion might be the solution. So if we can build some kind of fusion reactor, we can make them quite small. That might be a solution. But you still need reaction mass. You still need to be shoving stuff out the back. Could we all harvest energy from the suns? Well, we harvest energy from the sun anyway all the time. So the vast majority, this is from Sam, Mills and Nikki, we do that already. So basically something like about 95% of our energy comes from the sun as it is. So the only sources of energy at the moment that doesn't come from the sun is nuclear, so nuclear fission, and geothermal. So sun tidal. So everything else that comes from the sun. So we could potentially harvest more energy from the sun. So we could put solar panels out there and harvest energy from the sun. And that's one of the things people have been looking at. So have any of you heard of the concept of a Dyson sphere? So a Dyson sphere is this idea that that traveling to the stars is really, really difficult, but you're a civilization that is using more and more energy. So what you do is you build a sphere completely around your star. So you capture the entire energy of your star. Okay. So we've also been on the lookout for Dyson spheres as well. So it's one of the things we've been trying to look for, but we haven't ever discovered anything. It'll be really big news, obviously, if we discover a Dyson sphere. There was a star which was in the news a few years ago called Tabby's star, and I worked with a student who was investigating Tabby's star. And Tabby's star, it's doing some really, really weird things. And for a while we thought aliens. Now we don't think it's aliens. Yeah, Ringworld's another example. Alien. So Tabby's Star was really, really exciting. For a while, I thought it might be what's called a von Neumann machine swarm. So you've got lots of these self-replicating machines that was causing this star to change in a very, very odd ways. It was something we'd never observed before. But I think we've got a better idea of what's going on with the physics now. We think it's something inside the star that's changing. It's not external. Yeah. Yeah. So going to Alina, so it turns out that ring world. So this idea, instead of building a sphere, you build a ring around your star, and that gives you a really, really massive surface area. So it allows your civilization to grow, and it's a lot less resource hungry. So actually, there's enough material in the solar system for us to build a ring world. But the only downside of that is ring worlds aren't stable, so it would start wobbling quite quickly, and it would become uninhabitable very, very quickly. So I'm actually being told that I'm going to have to finish in 10 minutes. So I'm going to actually just do 5 minutes because I'm beginning to lose my voice. But carry on asking. We'll do a few more. And again, if you've written a question and I didn't see it, feel free to ask me. What about solar storms? Do you think aliens are going to look like us? Right. So if you can be a bit more, Robin, can you be a bit more specific what you mean about solar storms while I answer the question about aliens? So there's something called convergent evolution, which is this idea that things keep on appearing over and over again. So, for example, the eye has appeared in evolution loads of times. There's loads of different ways of doing an eye. In fact, some animals have mirrors instead of lenses within their eyes. So the eye is such an important evolutionary component in life. It's appeared multiple times. I think it's likely that they're going to look fairly similar to us, but we shouldn't be surprised if they look completely different. So, if you look at things like octopuses, which are relatively smart, they're about as smart as a dog, they look about as different from us as you could possibly imagine. They don't have a skeleton, they have 3 hearts, they've got a brain the shape of a donut, they communicate by changing their skin color. So potentially they could look like that. But I think that for a technologically advanced race, you need to be on the surface of the planet rather than be a marine animal. If you have too many limbs, it takes too much brain capacity to control your limbs, and we've seen that with other creatures. I think that that if you're too big, your body's too big for your brain to control it. So you end up with getting a nice, basically a human scale body and brain structure. So I wouldn't be entirely surprised if they looked like us. Back to Robin. Are their solar storms be close enough to Ken's solar? I think Robin's asking, can they be dangerous, solar storms? So star like the sun, occasionally they erupt and they throw off material. And back in the 1800s, there was one called the Carrington event. And that interacted with the Earth's magnetic field, and it basically caused amazing aurora, so northern and southern lights. But it also made the telegraph wires live, and people were getting electrical shocks. There was another similar event in the 1980s, and that caused the power grid in Canada to go off for a while. But we're aware of them now. So a big solar storm, isn't likely to cause us a huge amount of damage. You'll probably lose power for a couple of days, but it's just a case of throwing the circuit breakers. We are prepared for this sort of thing. Buzzard ramjets. Right. So Alana's read a lot of Larry Niven. So Larry Niven's what's called a hard science fiction author, and I used to read a lot of Larry Niven when I was a kid. And this idea of buzzard ramjet. So buzzard ramjets are feasible, but we still haven't cracked nuclear fusion. So if we have nuclear fusion, then effectively, yes, buzzard ramjets would probably work. But you're still going sublight. And the other problem is that as you get close to the speed of light, things like dust become absolutely deadly because they have so much energy. So the one of the space shuttles got a cracked windscreen from a fleck of paint hitting it at 22,000 miles an hour. The International Space Station has an area on it called the cupola, which is the windows that you've seen. That's got a crack in it. That was caused from a fleck of paint. So I'm just going to round up. So I'm going to take one last question. Who wants to give me the last question? Go on, type away. By the way, the reason why I'm not looking directly is I've got like 3 monitors and I've got my PowerPoint on one. Favorite experience? Oh, okay. So when I made my first discovery, so I was an undergraduate student. So I was working. I was doing my undergraduate degree, and I was doing some research with one of my supervisors, one of my university lecturers, and I was looking for a type of star called a white dwarf, and I was looking for what's called a cataclysmic variable. So these are white dwarfs that give off lots of X-rays. They're very active. They're drawing material off of new stars. And me and my supervisor wrote a computer program to trawl through this massive database looking for white dwarfs. And I tested my program over and over again, and I ran it on the live data. And within about 5 minutes, it said I found one. And I just didn't know what to do, because for a while I was the only person in the entire world that knew that object existed, and that was a great feeling, and it's never gone away. That moment where I'm now a proper scientist, I've done something no one else has done. Oh, actually, the first thing I thought was I've cocked up, because I couldn't have possibly found one that quickly. So it was literally within minutes it found one, and I did think I'd cocked up, and it didn't find one for another about 3 weeks. But yeah, so we generated a whole catalogue. But that's the moment when I went from being just a normal student to being a scientist. I'd actually made a discovery. It's not an important discovery. A lot of astrophysics and astronomy, stamp collecting, basically. But yeah, that was my favourite experience, and that's a great question. So I hope a lot of you will go on to do science, whatever science you do, whether it's biology, physics, chemistry. And a lot of really fantastic science is being done where those things meet now. I hope that you'll have that really amazing experience I did. So thank you very much. And yeah, thank you. Have a lovely weekend.